we need to solve this equation. Logarithm base 3 of square root of x minus 1 plus 1/2 multiplied by logarithm base 3 of x minus 9 is equal to 1. Before solving this equation, we define the range of possible values. Expressions under the logarithm should be greater than 0. X minus 1 is greater than 0. And the second expression, x minus 9, is greater than 0. Thus, we have obtained a system of inequalities. Solving the system of inequalities, we get the following. X is greater than 1. And x is greater than 9. Let's draw the coordinate axis. Here we have 1. And here 9. According to the inequality, the value of x should be greater than 1. According to the second inequality, the value of x should be greater than 9. As you can see from the figure, the solution of the system is x is greater than 9. So we found the range of possible values. Now, let's look at our equation again. Let's look at the coefficient 1/2. We can use the well-known formula for the logarithm. A times the logarithm base k of x equals the logarithm base k of x to the power of a. In other words, the exponent on the argument is the coefficient of the logarithm. Thus, we can rewrite our equation in the following form. Logarithm base 3 of the square root of x minus 1. As we see, the first term was left unchanged, plus the second term we rewrite in accordance with the formula. Logarithm base 3 of x minus 9 to the power of 1/2 is equal to 1. We can solve the resulting equation. As you know, raising to the power of 1/2 is equivalent to extracting the square root. So we can rewrite the equation in the following form. Logarithm base 3 of square root of x minus 1 plus logarithm base 3 of square root of x minus 9 equals to 1. Thus, on the right-hand side of the equation, we obtain the sum of the logarithms. Remember the formula of the sum of logarithms. Logarithm base k of a plus logarithm base k of b equals logarithm base k of a multiplied by b. That is, the sum of logarithm of a and logarithm of b is the logarithm of the multiplication of a and b. Then our equation takes the following form. The base 3 logarithm of the square root of x minus 1 multiplied by x minus 9 equals to 1. So, we got the logarithm of the product. To solve this equation, we need to recall what a logarithmic function is. When the base k logarithm of a is equal to b, then a is equal to k raised to the power of b. In other words, both of these equalities are equivalent to each other, provided that the value of a is greater than 0. We can write down our equation in the following form. The square root of x minus 1 multiplied by x minus 9 is equal to 3. Square both sides of the equation, and we get x minus 1 times x minus 9 is equal to 3 squared. If we solve the equation in parentheses, we get x squared minus 10 multiplied x plus 9 equals 9. Simplifying the equation, we get x squared minus 10 multiplied x equals 0. We take the common factor, x. X times x minus 10 is equal to 0. We have obtained two solutions. X is equal to 0, and x is equal to 10. All we need is to verify if our root values are in the range of possible values. As we remember, the values of x should be greater than 9. Consequently, x equal to 0 cannot be the root of our equation. Thus, our equation has a single answer. X is equal to 10. Good luck! Solve problems with the support of the Bank of Astana.